Okay. So this starts off pretty chill, just asking you to fall, basically the end behavior, right? So you need to check the ones that apply. On these questions, there's not much to show. So I'm not gonna, on these types of questions, I'm not gonna require work. You just need to know how this works. So write down the definitions and requirements I gave you in the notes, and then just check the boxes. So no big deal here. Now, if your question is odd, your function, if it is odd and the leading coefficient is positive, meaning the number on the highest power, which is 12 here, if that is positive and the degree is odd, then it's gonna fall on the left and rise on the right. It's gonna be first and last for this guy. Okay, so there's just a set of rules to remember. If it's even, you look at the number. If it's positive, well, they're both going to be facing upward, right? So rises on the right and the left. Number 3. Again, this was trying to mess with you a little bit. The highest degree is the 3. Then you look at the sign, it's negative, right? -7. So if it's negative, then it's the opposite. It rises on the left and falls on the right. Okay. So there's a list that I gave you, and if you just look up those notes or just look up end behavior, it'll tell you, look at the power. The highest power tells you the degree. So this is degree 3, which is odd. Then you look at the sign on the number on the highest degree, and then that tells you what's going to happen. Here, let me just Google one real quick. Here. In case you don't have the notes in front of you, or you don't feel like looking through your notes. Can you see this right here? Oh, that's a video. Go back. This right here. So odd degree, positive leading coefficient. So that would be just like number 1. This one right here is number 2. This is right. This is number 3. Anyway, there's not much to do there. So let's move on to number 4. Okay, number 4 is find all the real zeros of the polynomial. Okay. There is no solution, enter no solution. All right. Determine the multiplicity. Alrighty, so that means we're going to have to factor everything. First step would be factor, find the zeros, and then you talk about multiplicity of each factor. Okay. Determine the maximum possible number for the turning points. Okay. And here there is a formula. I believe there, if we said if you're high, well, basically you look at the degree, and 1 minus the degree is the total number of turning points. So if the degree is 2, right? Here's 2. We should only have 1 turning point, so it turned once. Right. So it has to be either A or D, because this one has 1, 2 turning points. This is a cubic function. This is cubic. Okay, so all those notes will be necessary. You need to remember end behavior, right? Let me write this down for you. Okay, so exam to review. So for questions 1 through 3, no end behavior or functions, polynomial functions. Okay. Number 4, let's go ahead and solve it together. given f of x equal to x squared minus 25, part A says find all zeros if they exist, basically. Part B says determine the multiplicity. They don't outright say, but they should say of each factor. C, determine the maximum number of turning points. All right, so first thing we need to do, so step 1 is factor f of x. So we should see that this is a difference of squares, right? This is back from the beginning, when we first started, we did factoring. So this will be x plus 5, x minus 5. So first step is factor. So step 2, set this to 0. And solve for x. So this would be x plus 5, x minus 5 equal to 0, which means you have x plus 5 equal to 0 and x minus 5 equal to 0. Solve for x and you will have these two values. All right, so those are the zeros. Once you have them, these are the factors. So determine what's the multiplicity. And they tell you to, well, of course on the exam it doesn't matter, but this was generated using like a homework thing. They tell you to put it in order, so this would not care about that. So this right here is part A. Part B. Multiplicity of this guy right here, x equal to -5, or x plus 5 is 1 because of the power. So you can say it as the answer or as the factor. Same thing though. X equal to 5 or x minus 5 is also 1. So there's part B. So far, any questions on number 4? Turning points is equal to the degree minus 1. In other words, n minus 1, where n is the degree of f of x. So in this case, for this example, n is equal to 2, so we have 2 minus 1 turning points. That is to say, 1 turning point. Any questions on B or C?
What is after the 1 on the first sentence in C? The degree minus 1 after that? What is that?
Oh, i.e.
I.e. Okay.
So do we have to say it's a parabola or a quadratic or?
Not on this question. But they do want you to graph it. So this is just a basic parabola. So you should know what it is. Go down to 25, negative. Looks something like this. Doesn't have to be perfect, just a decent sketch is fine. So that's it for number 5. Any questions on 5? Or any other questions? Right, let's do number 5 then. So that was number 4. Guys, okay on this page?
Yes.
All right, let's look at 5. Looks like 5 is the exact same thing, except the factoring is more complicated. Let's see if it's even worth doing. Yeah, let's go ahead and do it. On 5, I'll skip a few more steps because it's the same thing as 4. If you have a question, let me know. Okay. So part A is the same stuff. Find the zeros. Find the multiplicity for each zero. Find the maximum number of turning points. And graph it, I guess. Okay, so first thing, let's go ahead and factor. So they all have x squared in common, right? So factor x squared. That will give me x squared minus x minus 12. So this becomes x minus 4 times x plus 3. Okay, so each one is 0, so step 2. So that would give us this nonsense equal to 0, which would give us these three terms. Which means that x is 0, x is 4, x is -3. Any questions so far on step 1 or step 2? So this is part A. Step part B. Determine the multiplicity of each 0. So just look at the factors. Multiplicity of x equals 0, or x squared is 2. Multiplicity of x equal to 4, or the factor, is 1. Same thing for this guy. Is also 1. Okay. Any questions on part B? All right, so part C, maximum turning points is the degree minus 1, which is this case 4 minus 1 is equal to 3. All right, so that's part C. Part D, it's a fourth power function, so it'll be parabolic-like. It has these zeros, so what you could do is plot the zeros first. So we got a 0 at 0, 1 at 4, 1 at 3. Look at the end behavior. This is positive on the highest power, so it's going to rise on the left and right. It's going to be doing this thing. All right, so up here it does this. At -3, it's going to cross. At 0, it's going to bounce. At 4, it's going to cross. So this is my sketch. I don't know how low these go. That requires us to plot more points, but I don't want to do that. And you don't have to do that. Like, this is good enough sketch. So look at your solutions here. This is good enough. If you have a graphing calculator, cool. The graphing part, I'm not gonna worry too much about. The rest I will want to see work though. So right here you can see, right? It cannot be D because it crossed at 0. C crossed at 0. It has to be A or B. So you would have to plot at least one more point to see how far down this goes. See that this is not enough I mean, yours is not gonna be multiple choice, so you would be done already, but if you're curious, right? How would you choose the right one? You would have to plug in a negative, well, anything below the 0 is fine. -1, -2. Plug that into F and then see if it truly is above -100. Maybe it's supposed to be lower, like this one. This one's almost at -100. This one's closer to, looks like 40 or something. Does that make sense? Just rule it out. Alright.
I have a question for part B. When you get the multiplicity, is that just the power?
Yes. So
Okay.
it's just how many, multiplicity means like how many powers are on your 0, because it's a multiple. It's the same 0 being repeated. That's why they
Mhm.
call it that.
Okay.
But that multiplicity also determines if it's gonna cross. So if it's an even multiplicity, it should bounce off the 0 like A and B.
Mm-hmm.
Here they cross, which goes against the idea of even multiplicity.
Okay.
Okay, so any other questions on 5? All right, let's do synthetic on 6 and see how that goes. Okay. We'll skip 7 since it's the same thing. Use synthetic division for 9x cubed plus 45x squared plus 31x minus 20 divided by x plus 4. So if you're dividing by x plus 4, that means that -4 would be your 0. So take 9, 45, 31, -20. So these, make sure that you have every single power, 3, 2, 1, 0. So we're good. We don't need any placeholders. Bring down the 9. Sorry, start the algorithm. -4 times 9 would be -36. 45 plus -36, 9, right? -4 times 9 again. 31 minus 36. -4 times that is a 20. So 0. So that divided it evenly. So that means that the original polynomial here, you could technically write it this way, same thing, right? Same deal. This is equal to 1 power less. So squared plus x minus 5. So this division becomes this quotient using these coefficients.
So whatever would be in the place of 0 is just the remainder.
Right. So if there was a remainder, which technically there is, right? It's a 0.
Yeah.
It would be added this way.
Okay. And it's
this-
always going to go over the denominator.
Yeah.
Okay.
So is over the divisor. So the remainder divided by a divisor. Any questions on 6?
I have a question about this part too on the end. Is
Mhm.
that necessary to put that when there's a 0? Like when we get to higher levels of math, is it going to be more strict then?
No, it's unnecessary. This is not needed. You would only do that if you're trying to do something strange. If there was a reason for it, but it's not wrong. It's just unnecessary.
Okay, just asking out of curiosity.
Yeah, not required. No. Let's see here. Okay, so the next one is basically similar to the last, to the 4 and 5, except they're higher powered functions. Let's see here. Yeah, let's go ahead and do it. So given x cubed plus x squared minus 9x minus 9. Part A says find all rational zeros. Part B says sketch the graph. Oh, C. C says determine all zeros. All right. So what we're gonna do is synthetic division, because it's a higher powered function. We could probably get away with using grouping. But let's practice what they want us to practice. So to do synthetic, right? You gotta find all possible zeros. One second. Forget if it's this or that. Let me double check. Pretty sure it's gonna be P over, no, Q over P. Yeah, P is the constant term, Q is the leading coefficient. So possible zeros are going to be the combinations of plus or minus factors of 9 divided by the combinations of the factors of 1. So you look at the constant term, And the leading coefficient meaning the number on the highest power, which is a 1. So our possible zeros will be plus or minus 1, plus or minus 3, plus or minus 9. Does everyone remember how to find these? That okay?
Yes.
All right. Let me know if you forgot. So once you have these lists, you have to kind of try them out until you find a zero. Here we have a cubic. So once we find one of them, it'll reduce to a quadratic, which will allow us to do quadratic formula or whatever we want, right? Whatever works. So 1, 3, 9. I'm going to do that on the next page. And the function was this guy. So here we go. Start with 1. 3, 2, 1, 0. So we got all the values. 1, 1, negative 9, 9. Bring down the 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. 9, negative 9 plus 2 is negative 7. 1 times that is negative 7. So that does not work. Let's try negative. So bring down the 1. Negative 1 times 1 is negative 1. 1 minus 1 is 0. Negative 1 times 0 is 0. Negative 9 plus 0 is negative 9. Negative 1 times negative 9 is positive. Oh, I thought we almost had it there. Let's double check. Yeah. Oh, wait a minute.
Wait, so is that supposed to be -9? Oh, yeah. There you go, sorry.
Yeah, it's supposed to be. So that should be negative 16. This should be 0. So we found our 0. Okay. So now that we found it, that means that f of x equal to x cubed plus x squared minus 9x minus 9, that would be equal to the 0 we just found, so x minus the 0 times the leftovers, so x squared minus 9. So that becomes x plus 1 times x squared minus 9. And that is a difference of squares, right? So set it to 0. Once it's factored, let me see here. So this is step 2 here. Factor using synthetic. Step 3. Set f of x equal to 0. So we're going to get x plus 1, x plus 3, x minus 3 equal to 0, which means we have x plus 1 equal to 0, x plus 3 equal to 0, x minus 3 equal to 0. So x is -1, x is -3, x is 3. So those are all the possible zeros. So part B starts right here. It says sketch the graph. So it's a cubic. It has a positive number in front, so that means it falls on the left, rises on the right, has 2 turning points at most. It has these zeros. So So 0. Oh, I'm sorry. There's no 0. -1, -3, and 3. They are all odd multiplicity, right? So we said it's going to be falling on the left. So it's doing this. It's going to come down at some point. It's going to come up at some point. The only thing that I'm guessing is this part. I don't know how low and how high these get. So that's the guess I took. Everything else is fine. So that'd be good enough for a sketch. And the real zeros would be the same for part C, right? Any questions on part 8? Question 8.
Do you want us to graph it on our paper notes or on our paper? Or is it okay if we just select which graph we think it is on the test?
I don't know if it's gonna have to look at it. I don't know if it has like an actual test graph to select. But yeah, on the paper, just do a sketch.
Okay, thank you.
But if they have multiple choice for that, then I guess it doesn't matter. If there isn't, then yeah, give me some sort of basic graph. Okay. So that's number 7. I forgot. 8. That was 8. Nine is similar. 10 is different. So let's move on to 10. Find all vertical and horizontal asymptotes of f of x equal to 5 minus 7x over 5 plus 9x. Now we said to find the vertical, you set the bottom part to 0 and solve for x. So subtract that over, divide by 9, gets you to here. So this is my vertical asymptote. Horizontal, we had a 3 set of rules in the notes. We said you have to look at the degrees. So it all depends on the degrees of the top and the bottom. So if they are the same, we said the horizontal will be y equal to the leading coefficient of the top, which is -7, divided by the leading coefficient of the bottom. So that's it. It just depends on the scenario. And we said if the degree is bigger on the bottom, then the horizontal asymptote is 0. If it's bigger on top, then you have an oblique. Okay. So that's 10 and 12, or 10 and 11, sorry. Number 12 is kind of similar, but it asks for more things. It says, what is the domain? What are the intercepts? And find any vertical or slant asymptotes. So since the degree is bigger on top, it will have a slant, sadly. We won't worry about this because I'm not going to have you do that type of stuff. But okay. 12. So consider the following. F of x equals 2 x cubed over x squared minus 16. Let me switch back. So first thing is find the domain. So in order to do so, you have to figure out if there's any areas or any values you cannot plug in, any problem areas. And when you see a rational function like this, you should think, okay, something's gonna be a problem at the bottom because you could maybe have division by 0. So to check for that, what you got to do is set the bottom to 0, factor, and then you find that x plus 4 is equal to 0, x minus 4 is equal to 0. And then we get these two values. So these are vertical asymptotes. It's the same process up here, but they didn't ask for it. We just need to know that these values are holes in the function. Either they're undefined in the function, basically. So to find the domain, you write this value down and kind of piece it together. So everything below -4 is fine. So -infinity to -4 is cool. Everything in between is cool, but not those end values. Everything after 4 is fine. If they wanted the domain in interval notation, you would write the intersection of these 3 pieces. Or sorry, the union. I don't think it asked. Let's see. Yeah, I just want you to say it in plain English. So check it out. They said all real numbers except -4. Well, that's true, but +4 is also a problem. So you would say all real numbers except plus and minus 4. Plus and minus 4. Okay, so C. Any questions on part A? Switch.
When we're writing for the domain, after that, like say, for example, that first section there, -infinity to -4. Would that be a bracket or would it not matter? Or it just stays as a parenthesis?
It has to be parentheses on the -4 and 4s, because those are not included, so you have asymptotes here. If you put a bracket, that's understood to mean all the way until -4 is fine. Parentheses means right before -4 is fine.
Okay, I got it, thanks.
And infinity is not a number, so you can never put a bracket on that guy. Okay. Any other questions on 12A so far? Identify all intercepts of f of x equal to x cubed over x squared minus 16. Okay, so same question, same function. Remember we said to find x-intercepts, let y equal 0 and solve for x. To find y-intercept, let x equal 0 and solve for y. Of course, in this case, y is f of x. But same thing, right? So let's do the x-intercept first. Set this equal to 0. The only way this would be equal to 0 is if x is equal to 0. The denominator will have won't do anything for you. If x is 0 though, then 0 divided by anything is 0, so it has to be 0. Y-intercept. Plug in 0 for everything, every x. In this case, it turns out to be 0, so f of x is 0 or y is 0, same thing. There's your intercepts. Turns out the intercept is is 0, 0. This is part B, okay.
Yes.
All right. Part C asks for any types of asymptotes. Okay, well, the vertical we kind of already found, right? Look back over here. These are the vertical. So we can have, it can be 4 or -4 because those are asymptotes. It makes the bottom 0. So the vertical asymptote will be x equals 4 and x equals -4. There's no horizontal because the degree is higher on top. So you're gonna have to do long division to find the oblique, which sucks. So here's x cubed plus 0x squared plus 0x plus 0. Gotta fill in the blanks. X squared goes into this guy, x times that is x cubed. X times negative 16 is negative 16x. Switch your signs. That gets us to 16x. Cannot go any further. This is too small. So the oblique will be in just the x. Let me check. Number 12. Yeah, should be just x.
Wouldn't it be y equals 16x or
Let me check. Might be right. It was x cubed on top divided by x squared minus 16. No, it's just the x, just this guy. Okay. So that was C, and yeah, that's pretty much it. So we got vertical asymptote, oblique asymptote. And this question, the intercepts weren't that interesting because it was the same point. So whatever. But this is the rules for finding them.
yeah, so a question, so what do we do with the 16x? Is that like the remainder or?
It is a remainder, but it doesn't come into account for the oblique part.
And then our question is, how do we find the turning points if it's a division?
They didn't ask for turning points.
Uh,
And it's not a polynomial, it's a rational function. So the same rule wouldn't apply. Okay. Do 13. You realize how long this review is. Interesting. May have to do more next time too. Solve the inequality. X plus 2 squared less than or equal to 9. So the idea is factor or square root what you can, and then deal with this inequality. So we're going to have to square root both sides here. But when you square root, you have to tack on the plus or minus. So we're going to get x plus 2 less than 9 or equal to x plus 2 greater than or equal to negative 9. Actually, I think it's just greater. Yeah. So the minus flips it and gives you the opposite inequality. So that you'll solve right here, x would be less than or equal to 7. X would be greater than -7. So put this together, right? So here's -7. Here's 7. So if it's less than or equal to 7, that means I'm going to include a bracket here all the way until -7, but I put a parentheses there. So everything in the middle is great. The only one I cannot include is -7. And of course, everything outside would not be included. So whenever you square root, it creates a plus or minus, and the minus will flip direction for that part. Does that make sense?
Wait, say that again? Sorry.
So whenever you square root anything on both sides, you got to tack on the plus or minus. But there's a rule for inequalities that says, let's say you have x less than 2. If you multiply by a negative, it switches direction. So tacking on the plus the minus part to one of the pieces. Oh, shoot. Should have been a 3, shouldn't have. Let me switch this a little bit. The only thing that will change is this number here. Be -1 and 1. -1 and 1. Maybe picture a bunch of little fractions in there, I guess. But you see what I'm saying with the rule, right?
Yeah, so like the x is greater than -1 doesn't need that greater or equal to -1 because it's it's positive. Is that
Yeah, it's always gonna switch to the opposite. Let me, yeah, it'll just switch to the opposite. So if this was if it was greater than, it should switch to, sorry, if it was less than or equal, it should be just equal to greater than when it flips.
okay?
Let me double check that idea real quick.
I have another question.
Uh-huh.
What about the test where are we supposed to like test the point between the -1 and 1 or?
That would be for the polynomials types.
Okay.
But we could test the endpoints to be sure. Oh, I think that's a good idea. If I plug in 1, right, you see that this would be 9, right?
Yes.
Which would be true. So putting -1, this would be 1, which will also be true. So then we can include it. So yeah, we should check no matter what. Just to be safe. There's actually a bracket. So I think it should stay this way, since this will be true. Let me find my book really quick. But if it's like a quadratic, then you should, for sure, you should check.
So if it's less than or equal to, it means that both sides have a bracket.
If it, yeah, if you can plug it in and it works, then you got to put a bracket. If it doesn't work, then you got to put a parentheses. Okay. Let's move on to something else. Let's get to the logarithms, because We just talked about those. We should practice them some more. Number 16. Use the 1-to-1 property. So 1/2 to the x equal to 32.
And a question, so is this where we look that they have the common basis, or do we do the exponents, or?
Well, I'll be for this one, if it says 1-to-1, then you should try to match it. I mean, you can match them, but I don't care how you do it. Just use your properties or match them, it's fine. But the whole matching idea only works for these types. If you were to match it, you would have to bring this up top first and change this to a power, because that's 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So this is 2 to the 5th. So -1 raised to the x, that'll be 2 to the negative x equal to 2 to the 5th. So at that point, negative x is equal to 5. Solve for x. Is there any questions on that idea? If you wanted to use the log properties, even though it told you to use this, I would be okay with it. You could have said, let's show this, let's write the first part. Starting with 1/2 to the x equal to 32, introduce ln, or any log of your choosing, preferably something on your calculator. Use the power rule to bring down the x. Divide that logarithm on both sides, right? You'll have so x will equal ln 32 divided by ln 1/2. Which will become -5 if you plug it in your calculator. So either way, for this question, this method only works sometimes. Okay. One moment. Okay. Yeah, you know what, let's stop here because it's a lot of material already. You guys have any questions on your homework? You guys doing all right with everything? You have any issues or concerns?
And the week 10 is closed. Was till yesterday, but
They should be open now. Which week?
it was till the 31st of week 10.
Yeah, it's open now. I've opened all the weeks until the end. So if you want to get ahead, you can. All the way until the final. But yeah, if there's any issues, let me know. But they should all be open now and working.
Oh yeah, thank you. I see it, yeah.
All right. There was someone said there was a homework they wanted me to open, right? Unit 2. Let's see. Unit 2. Go ahead and open that.
I have a question.
Mm-hmm.
How many questions on the test?
Oh, let me check. Let's see.
How long is the test for?
I haven't looked at it in a while. Give me a sec.